Hi, I'm David. Let's look at this problem. We're given the definite integral from 0 to square root of 3 over 2 of 1 over 1 plus 4x squared with respect to x. I've rewritten the problem and I've left myself a little space to work right there. Okay, when we see an integral that looks something like this, we've got to ask ourselves, do I have some sort of formula that helps me deal with this? Well, this is definitely a fraction, a numerator and a denominator. So unless I can rewrite this algebraically, I'm going to have to use some sort of formula that has a fraction. Well, we have a couple of those. We have one involving the natural log function. We also have three involving inverse trigonometric functions, arcsine, arctangent, and arcsecant. So perhaps one of those could work. And if we look at this, we might recognize that this looks a lot like the formula involving arctangent. So let's write down that formula. That formula says the integral of du over u squared plus a squared equals 1 over a times arctangent of u over a plus c. Okay, can I do some sort of u substitution that fits this integrand to look like this integrand? Well, a couple of things to recognize here. First of all, on the denominator, I'm adding. So the order of addition does not matter. I could add a constant plus a variable, or a variable plus a constant. So that doesn't really matter. In this u substitution, u is my variable and a is a constant. So let's just start trying to see if we can make this work. If it is going to work, what do we know? We know that 4x squared has got to be the same as u squared. So let me write that equation down. U squared equals 4x squared. Well, I'm going to want to figure out what u is, so I could think of 4x squared as the quantity 2x squared. So u would then be equal to 2x. And I'll need to find du. The derivative of 2x with respect to x is just 2, so du is 2 dx. Okay, so if I wanted to, I could rewrite this integral as the integral of, let's see, this blue 4x squared could be turned into a plus u squared. All right, what else can I do? Well, I need to deal with this a squared right here. And I'm going to want this a squared to be the same as this 1. Well, that's not too hard. I could set a squared equal to 1, and then a has got to be equal to 1. So if I like, I could rewrite this one as an a squared. And that looks just like I want it to in this formula. Next, I need a du in here somewhere. Well, my du is equal to 2 dx. I need that somewhere in here. I have a dx, but I'd really like to have a 2 dx. So let me multiply by 2. But I don't want to change the integrand, so I'll also multiply by 1/2. That doesn't change anything at all. But now this 2 dx is the same as du. And I could just as easily write that on top of the fraction as I could over here to the right. So I'll go ahead and write that 2 dx as what it is, a du. Okay, a couple other things I need to deal with. This 1/2 is a constant. I can write that constant wherever I like. So let me go ahead and put that out in front of the integral sign, right there. One final thing I need to deal with are these limits of integration. This is a definite integral. So my final answer is not going to have a plus c like this indefinite integral, but it's going to be a number. So I need to change these limits of integration because while x is going from 0 to square root of 3 over 2, u will be going to something else. So let's try that. If x equals 0, that's my lower limit of integration, then what does u equal? Well, I've got a formula right here for u. U equals 2 times x. So in this case, u would equal 2 times 0, or 0. So my lower limit of integration changes from 0 to 2 times 0, so it really remains the same. But now it's with respect to u. My upper limit of integration with respect to x is square root of 3 over 2. Well, that means u is equal to 2 times the square root of 3 over 2, which is the square root of 3. Okay, so my new upper limit of integration is the square root of 3. Okay, now I've done a u substitution and I've rewritten this problem in the form that it is right here. The only thing that's different is that a is really equal to 1 right here. So let me go ahead and keep on going. This equals 1/2 times, well, I know what this integral is. It's 1/1, because a is equal to 1. Arctangent of u over 1, because a is equal to 1. Now you might be thinking to yourself, well, shouldn't you replace u with 2x? Well, I've already changed my limits of integration, so I don't need to plug back in for what u was, because I've changed my limits of integration. Okay, and then I'm evaluating that from u equals 0 to u equals square root of 3. If I can do that, then I've solved the definite integral. Well, a couple of things simplify. I've got this 1/2 right here. That can stay there. And then I can write this as, let's see, the 1 doesn't matter. 1/1 is just 1, so I can not write that. And then I can write arctangent of square root of 3 over 1 is still square root of 3, minus arctangent of, let's see, arctangent of 0. And then finish up there. Well, I've got to know what arctangent of square root of 3 is and what arctangent of 0 is. Let's remember what that means. Arctangent of square root of 3 means tangent of something equals square root of 3. Well, the value defined for arctangent that gives me a square root of 3, tangent of pi over 3 equals square root of 3. Similarly, tangent of what gives me 0? Well, tangent of 0 gives me 0. So my final answer is 1/2 times pi over 3 minus 0, or if you like, pi over 6. So in this problem, whenever we see something like this, with 1 over a constant or a constant squared plus a variable squared, arctangent should really pop into our minds as a possible option. Thanks for watching.